Thank you, Katya. Hello, everyone. I will share my screen in a second. Okay, so I will talk firstly about the optimal sizing calculator, which is the tool with Excel user interface. Here you see a screenshot of how it looks in Excel, but we will go through it a bit later. So the idea with energy storages is also increasing energy from renewable energy sources. So if, for example, if you have a situation where you have a consumer that buys energy from the public grid, you can add, for example, a PV system, so you can increase energy from renewable energy sources, but the consumption of the consumer doesn't match with the PV production usually. So you can always feed in the extra energy, but these feed-in prices are not so favorable. Well, Robert explained that in Austria it could be, but it's not always the case. But while adding the battery storage, you can increase your flexibility. So after the actions, so you have a consumer with its own consumption profile. You have a PV system with also fixed production profile, sorry. And then you have a battery energy storage system, which can either charge or discharge. So the energy flow is both ways. And also to the public grid, the energy can flow both ways. And the idea of the optimal sizing calculator is to find the optimal sizes of this battery energy storage system, as in battery capacity, and the size of the power converter, and also the size of the PV system. So it's peak power at standard test conditions. And this calculation is based on the yearly consumption profile of the consumer, but also the production profile of the PV system is taken into account. So some of the features of the tool. So the user chooses the country, and the prices of electricity are stored as in autarky rate tool in the background, and also separate prices for buying and feeding of electrical energy. So the user can also choose is the peak power billed or not. And the user also enters the desired return on investment period. So for the yearly consumption profile, there are all generic profiles, same as in the autarky rate tool, but there's also option for the user to upload its custom user profile, so the calculation can be more accurate if the user has that profile. And the profile means 15-minute samples of mean power during a full year, so 35,040 samples of mean power. So for the production of the PV system, the solar, there is in the background, there is a profile of solar irradiance and angles of the sun. So the actual production profile is calculated according to orientation and inclination angles of the PV system. And for the battery storage system, there are charging and discharging efficiencies, but there is also battery degradation included, because the batteries have certain amounts of cycles they can go through. One cycle is full charge and then full discharge. And so it can be calculated according to the capacity, number of cycles, and its price. How much does it cost to charge or discharge 1 kilowatt hour of energy into the battery? And the tool itself is available at Store4HUC website. So, sorry. So if you go to the website and under the tools, you can find the optimal sizing calculator, and you can click and download it. I have it already downloaded, so I will show you how it is used. So everything comes in one zip file. So if you need to extract it, and you get a folder with everything needed inside. You have a README file with these simple steps what to do. And then the main file is this Excel file with macros. So open it and I'll show you, of course, because it is downloaded from the internet, it probably ask you to enable macros, so everything in the safe. So how to use it? We have some basic parameters of the consumer, battery storage parameters, and PV system parameters. So for start, I will just enter some of the parameters just to show you. So let's say the site is in Austria, consumer is household with 2 children, and since it's household, the peak power is probably not built. Let's say they consume 6,000 kilowatt hours of energy, and they want pay off the investment in 15 years. And maximal possible investment doesn't matter because the tool will limit to this maximum payoff period, but you can also limit the investment. Also, there is 3 different optimality criterion, because we are finding optimal sizes, but what does the optimal mean? So it could be either yearly amount of energy taken from the grid, it could be cost of that energy exchanged with the grid. These two might seem similar, but the difference is because if the peak power is built, it's not only energy that is inside of the cost. And also there is total yearly spending. So it's all the energy exchange with the grid, peak power, and also the scaled yearly investment. So all the investment in total divided by 15, so you get yearly investment. And there is also cost of the yearly maintenance. Some battery storage parameters and PV system parameters come some as default, so you can just click on calculate optimal sizes, and the tool will start. So under here, you have part with messages, because it takes for the tool some time to calculate. You have here down in the status bar, it says calculator is running. So the time required for the calculation takes at least 10 minutes, but it could go up to a few hours depending on the selected parameters. So I went through all this quickly because I just wanted to start the calculation, because it will take around 10 minutes, I think. So I will go once again through all of the parameters. For the battery storage parameters, we have number of cycles for the battery. As I explained, this is important for the degradation of the battery. And also depth of discharge, as batteries should not be discharged completely in the long-term run. We have charging and discharging efficiencies. We have lifetime of the power converter. This is the power converter of the battery system, not the PV system. And so it's total price divided by this and the number of years of lifetime. It's taken as yearly maintenance of this part of the system. We have prices both for battery pack and for the power converter per unit of energy. And for the PV system parameters, we need to include the maximal possible peak power. This can be calculated if, for example, you have a building and you want to put a PV system on the roof. So you are limited with the area of the roof of how many solar panels you can put there. So that's this maximal number. So then you have orientation, you can choose and write your inclination angle, same as in autarky rate tool. Also, you have the lifetime of the PV system. So for the maintenance calculation, and you have price of the PV system per unit of peak power. So this is still calculating. I can show you, for example, the results of one of our pilots. Let me just open it to show you how it looks. Okay, so this is the example for Croatia, Bračak Manor, one of our pilots. And after some time, the calculation showed the results, which are pretty similar to the numbers that are actually installed on the site, which confirms that the calculation is in sync with the actual pilot actions. Down here, you can see all the messages the tool sent. So these messages are pretty technical. This is the mathematical calculation, what it is doing, but it is mainly to show the user that the tool is still calculating, even if quite some time has passed. Okay. And back to the presentation. I would like to show you that there are also video tutorials. There are two video tutorials, one for basic installation and running the tool, and the other one with detailed explanation about all the parameters needed for the calculation. Mathematical background is described in detail in the project's publication. It's one of the deliverables, but also there we have published a scientific article about these calculations. So do you have maybe any questions